Hello, this is DrPaulCottrell, and I'm recording this on January 2nd, 2025. So there's a couple things, a lot has happened in the news. Obviously the Cybertruck and what happened in New Orleans, and, the inauguration that's coming up, right? Some facts about terrorism, that happened on New Year's Eve/day. A lot has happened in the news, all right? And I will cover that. But there's something more important breaking than the Cybertruck or what happened in New Orleans. And that is this growing concern of pneumonia or white lung, but pneumonia cases in China that has been reported in the news in some smaller independent websites. So the validity of it, I can't confirm with that. There's some reports in China that's taking place, and NTD did an expose on it about 3 days ago to 5 days ago. I think they did 2 of them, all right? I haven't been able to see the full video of it. There seems to be reports in Asia, that means Taiwan, Japan, China, and even India, of human MPV. Now, MPV, for the ones that don't know, is metapneumovirus. Now, what is it? Okay. Most of the medical community doesn't know what it is. Why? Because it's new. It was first discovered in 2001 by patients in the Netherlands, or samples that were provided to them in the Netherlands. I'm not sure where the patients came from. I did post on X the actual paper of the discovery of this virus. I have not gone into the details of that paper, all right? But it was discovered in 2001 with a series of respiratory infections, and then they sequenced it, right? All right, and in that paper, it goes into detail on how they did that. hMPV, human metapneumovirus, all right? Metapneumovirus, the human version, discovered in 2001. NIH started issuing large sums of money over multiple years, starting in 2003, on sequencing and also cell culturing and the study of human MPV. Now, human MPV comes from avian MPV. Avian MPV was discovered in around the 1970s. It seems to have deviated. Human MPV, according to modeling, mathematical modeling, Bayesian modeling, and genomic modeling, that it deviated about 133 years ago. Some estimates go, just under 200 years ago, all right? But in that area of, like, let's say the 19th century, okay, we were playing around with cells in the laboratory from different animals and different species. Is it possible that what caused the divergence is the manipulation of things in the laboratory back then, unknowingly, that made the deviation happen? Very possible. all right? But we don't know for sure. There are some really interesting features. Now we have to kind of get back to Barrick's lab, all right, for a second. Barrick did not work on hMPV. Barrick worked on coronaviruses, worked on dengue viruses, and also norovirus. I was going to do some lectures on norovirus, but then the news announcement that came out with China. So the United States started funding a lot of research in hMPV back in 2003. It was discovered in 2001. 2001 was when a lot of money was starting to funnel in from the NIH for biodefense. And that's what some of that money was given to Barrick, the development of SARS platform. Okay, that's SARS, right? That's where SARS came from. All right, so we have that issue. That's the backstory. So China, fast forward to today, China is having respiratory problems. Now, that's not uncommon for this season, this time of the year, where you're going to have the rhinoviruses, the enteroviruses, the RSV and influenza. This is the season for that kind of stuff. The beta coronavirus, the adenoviruses. All right. So there's an increase relative to prior months. Currently, year-over-year data shows SARS-CoV-2 to be less. This year is less than last year. All right. Influenza is less this year than last year, but it's on the rise. All right. People in certain cities in the United States are starting to develop certain types of respiratory problems that seem to linger a little bit and then calm down. All right. Now, is it just a, seasonal dynamics? Who knows? All right. China has added additional provisions for surveillance of patients to determine what they have because of this flu-like illness. All right. In addition, the WHO is still complaining that China hasn't provided enough data on the 5 years of COVID that happened in China. So that's another data point. Now, hold on, I gotta plug it in. Run out of battery. So the point I'm making here is that cases are going up in China on various different pathogens. Mycoplasma, pneumonia. You have an increase in SARS-CoV-2, influenza, RSV, hMPV. And there are cases in UK, in the United States, and elsewhere where you're having 1 or 2 that are contracting bird flu from wild birds outside of the dairy and poultry farms. And you're getting more cases of norovirus. Okay, that was the reason why I was going to do norovirus. But the point here is these are the data points that are happening right at this moment in time. You have an uptick in certain types of viruses Norovirus is one, which is highly contagious, but can be controlled by stop eating shellfish and, and proper cleanliness and sanitation, and it'll die down. But it can be passed easily from one person to another. So that's the reason why norovirus spreads on ships all the time. Okay, so you have these different pathogens that are popping up. Some are foodborne, but highly contagious, and you have others that are respiratory. You have this fog issue that people were complaining about that smelled like plastic in some areas, and having some sort of irritation, pulmonary or throat irritation. How much it manifests, I don't know. It doesn't. I don't know if it manifests that much. Is it microplastics? Is it something else? Who knows? That's another data point. Okay, but specific to MPV, China's cases are going up, and they're concerned about the overflow in the hospitals, and that they've added additional surveillance and tracking and testing and all this stuff. So they're concerned that something is happening within their population with pulmonary infections that look like it's presenting themselves in the clinic as pneumonia. All right. MPV has been detected there, and it's increasing. Question is why is the mainstream media in the United States not talking about it? It's some of these smaller websites that are talking about it. And I'm not a big fan of NTD, because NTD seems like CIA, PSYOP, all right? So I don't know if, how much to believe what NTD is saying. But some of the Indian broadcasters are covering it, and some of inside Asia's broadcasters, that because of the lack of translation, it hasn't take hold yet in the mainstream news. Okay, so that's the problem. So there's MPV is a problem. It's a respiratory issue. There is no treatment. There's no treatment for MPV. None. All right. There's no inoculation for it that's been developed. Another data point. Back in 2019, Moderna was working on a platform for their RSV, and I'll explain why, RSV and MPV inoculation back in 2019. All right. And was given, additional funding? No, the additional funding was for, hold on, I gotta take a look at some of it. I think the additional funding was for something else. 178 was for, double check. Okay. In 2019, the developing platform for a combo inoculation by Moderna for RSV and MPV is mRNA 1365. Okay, it's in phase 1 trials. This is according to their website. All right. Now they announced in 2019 they were developing this. Now, why was it that they felt the urge that they needed to develop RSV and MPV in 2019? All right. Now, it seems to me that they've been really focused on respiratory inoculations. RSV is a big one. MPV is a big one. Influenzas are a big one. They have the some sort of pandemic influenza platform that's tied to H5 and H7 epitopes. That's the funding that they received for 178. So Moderna was funded a lot for SARS-CoV-2, funded a lot for H5N7. I'm sorry, not N7. Let me backtrack. H5H7 epitopes. And they were developing in 2019, and it's still in phase 1. I don't know why it's taking so long. The messenger RNA 1365 platform, where it's a dual for RSV and MPV. Now, why would they do a dual? I did a lecture today about the overview of hMPV and the structure, the genome, how it shuts down the immune system. I'm going to go over that a little bit in this video. But there is similarities to RSV and MPV. Now, remember what I said. Human MPV spun off of avian MPV about 133 years ago. Okay? That's the estimate. So it's relatively new. Now, why is it relatively new? Now, that's the mathematical kind of like trying to, assuming certain types of mutations and all this. It seems as though that's when it deviated. It was discovered in 2001 during funding for a biodefense program in the United States. Now, is it related? I don't know. I'm just saying these are data points. Could be unrelated. It could be related. I don't know. But the thing is that there's a lot of similarities, obviously, to hMPV and aMPV. But there's a lot of similarities between RSV and how it docks to the cell, how the genome structure is. It's very similar. The differences for RSV is that it has two non-specific proteins, right? That are 1 and 2 in the front of the genome and at the 3' area. They're both negatively sensed RNA. They have SH protein. They have the F protein and the G protein, and how much homology between any given protein between RSV and human MPV has to be investigated. I don't know. I suspect there's quite a bit of homology in certain proteins, and the arrangement, where SH protein is different for, let's say, RSV versus MPV. The same thing with the G protein, right? So there's some movement around, but it's very similar. It's very, very similar. So because it's so similar, and it infects the cell in a similar way, that creating a inoculation platform that knocks out MPV and RSV, there seems to be some logic there. Now the question is like, how much homology is in RSV versus MPV, either because of just nature or because of some sort of thing that humans were doing in the laboratory. Who knows? All right. But that's another data point. Moderna's working on a platform that started in 2019. All right. Remember, COVID, right? My understanding was October of 2019 when they said they were going to start doing this. All right. So there was October of 2019. Well, that's around the time when Event 201 was happening. It was in October. So there's my gut feeling here is that, and I've been saying this for a long time, the weakening of the immune system, and that there was going to be a multiple pathogen hit. All right. Now, is that multiple pathogen hit H5N1? Is it RSV? Is it MPV? Is it a combination? Is it the chimera that I've been saying, that it's either the fourth or fifth cocktail, either between SARS-CoV-2 and influenza or SARS-CoV-2 and HIV? The fifth cocktail is SARS-CoV-2 with HIV. The fourth cocktail is SARS-CoV-2 with influenza chimera. So it just seems as though they were preparing for something. It seems as though they were preparing for something. Now, is it possible that we're at a stage where we need to worry about hMPV? We don't know. One, we don't know the data that's coming out of China. We don't know the severity of the cases in the clinic. And it doesn't seem to have really taken off yet in other nations. But it is a serious respiratory issue for pediatrics and for geriatrics. There's no treatment. And it's a relatively new virus, and we knew a lot more about beta coronaviruses, in the good old days of 2020 than we do about hMPV virus, right? It's a relatively new virus. There's many things that we don't know about. All right, so with that said, those are the data points. And what I want to do is I want to go over a little bit of how, and I go over in detail on the previous video. It's called Overview of hMPV. So please watch that video if you haven't already. So there are a series of proteins that are on the virus, in the packaging. There's a series of proteins that surround the negatively sensed RNA. There's a fusion protein and there's a glycoprotein, a G protein, right? That G protein, the glycoprotein, attaches to a receptor, and the fusion protein helps the virus to fuse with the cell, and then it will release its RNA that's negatively sensed. Now, the proteins that help to shut down the immune system in the cell, because there's an innate immune system in the cell. And I go into detail in the video about overview of hMPV. SH protein, okay? The SH protein shuts down NF-kappa beta. Now, what else shut down NF-kappa beta? Messenger RNA platform. All right. Phosphoprotein, so it's P, phosphoprotein shuts down RIG1 and MDA5, okay? The glycoprotein not only attaches to a receptor, and I'll tell you what that receptor is in a sec here. Not only does it attach to the receptor, but it also, when the protein is made in the cytoplasm, it can inhibit also RIG1 and MDA5, just like the phosphoprotein, P. And then there is a matrix protein called M2.2 that inhibits MAV and also MyD88. Okay, MAV, M-A-V-S, or MAVs, I should say. M-A-V-S, so MAVs, and then MyD88, so MYD88. So the MYD88 is basically shutting down the signal from the toll-like receptor 7. I think it's toll, yeah, 7. And that will prevent the cell from going into a pro-inflammatory state and signaling infection. The MABs shuts down, it's blocked, and it shuts down activation of NF-kappa beta. All right, and it also helps to shut down the IRF3 pathway. So you have you have 1, 2, 3, 4 proteins that shut down the innate immune system of the cell, coming from human metapneumovirus. Okay? So there's a complexity to this virus that's a little bit different than the beta coronavirus. Now, I'll go into detail about the similarities and differences of RSV. I suspect that these proteins, because they're similar, have a RSV shuts down the innate immune system in a similar way. Now, this kind of makes sense why younger patients and older patients are susceptible to this. Okay, pediatric patients, especially very young, that first year or so, or a little bit, that first 6 months to a year, they're susceptible. Why? Because they don't really have an adaptive immune system, right? So because they have a very nascent adaptive immune system, they have to rely on their innate immune system or whatever antibodies they get through breastfeeding until they reach about 6 months, all right? But the thing is that pediatric patients with MPV, at least in China, those cases are pretty prevalent in the cohort group that's 14 years and younger, and also geriatrics that are 65 and older. So, okay, so you have an innate immune system with the very young, where it's basically that is the system that they have, and their adaptive hasn't come online yet because they haven't matured enough. But once you get past that 6 months to 1 year mark for the pediatric patient, then they have an adaptive immunity that kind of kicks in. All right. The problem here is that because of the environment that we're in, kids that are like 5 years old or 10 years old, they went through COVID, and they may have a weakened adaptive immunity because of inoculations or because of the natural pathogen. All right, their immune system isn't as robust as it should be. This is what I call the AIDS-like syndrome. AIDS-like syndrome. The immune system isn't working properly. The CD4s, the effective CD4s aren't working. There seems to be some sort of downregulation of CD4 and CD8. Okay, maybe the count is right. Maybe the count seems normal, but the effectiveness seems to be down. So there's that component to it. Maybe it's a weakening of the immune system because of the crisis in 2020 for some of these patients. And then when you look at the geriatric patients, your just immune system starts to get weaker as you get older. That's just the natural process of aging. This is the reason why I keep on saying it's so important to take care of your health and improve your immune system. So you have these two groups in China where you have this weakening. Something is there seems to be, they're more susceptible to an MPV. All right, the metapneumovirus. All right, so they're susceptible. Are they susceptible because of a weakening of the immune system? Because of the COVID era? Or are they susceptible because of the natural dynamics of their immune system at that age and how MPV inhibits the innate immune system in the cell through these 4 proteins that I talked about, the SH, the G, the P, and the M2.2 proteins? Who knows? All right. It's just some data points that potentially can allow for one to create hypotheses and move forward. All right. But my gut feeling here is that because we're hearing a lot about RSV, and RSV does work similar to MPV, that it's a little bit of both a weakening of the immune system because of age, and also the weakening of the immune system because of what these patients went through during the COVID year. Now, it doesn't make sense if, let's say, the patient is 1 year old, all right, and they didn't go through COVID, right? Then the question is, were they inoculated or not? If they were, then it's a problem. If they weren't, then you're talking about these exposures with MPV is most likely because they're about 1 year old, right? It's most likely because they just don't have a robust adaptive immune system and be able to handle this, right? But their innate immune system should be relatively robust by age 1.5, 2, right? So there's some unknowns to how MPV really, why is it these two distributions? Immune systems are weaker, just independent of the crisis of 2020. Immune systems are weaker in pediatric patients when they're super young, but you also have 12-year-olds. Well, their immune system should be relatively robust. So why is the MPV being a problem with these patients? And why is RSV being a problem? And this leads me to these older pediatric patients did go through COVID. So, there's no answers here. It's just questions. There's a lot of questions, right? But you have 4 proteins that for sure shut down the immune system, the innate immune system in the cell, and prevent the cell from going into apoptosis. It gets hijacked in replication of the virus, and it can't signal adjacent cells that there is a viral infection. The signal, sometimes there can be a signal that's sent through these cytokines and interferons that leads to an antiviral wall created in the tissue that's shutting that down. Very similar to the mechanism of shutting down the NF kappa beta pathway that the messenger RNA platform does. All right, because it prevents certain signaling. You get a viral DNA that comes in, or RNA, you get a signal, hey, there's something foreign, and normally the cell tries to kill itself and warn the other cells. All right. Well, the messenger RNA platform, because of the pseudouridine, helps with preventing that signaling process, and it shuts down the NF kappa beta pathway and other pathways, but that's one of the pathways is the NF kappa beta pathway. So, and the elongation factor. So what happens is when a cell thinks that there's some sort of foreign code in it, it'll say, don't allow for the elongation factor to work, right? But the messenger RNA comes in with the pseudouridine and it fakes it. It fakes the cell to thinking it's not foreign. And because it thinks it's not foreign, it doesn't shut down its elongation factor and allows for the production of protein that messenger RNA is supposed to be made, that is designed to make. That's why the maternal platform works the way it does. It shuts down the innate immune system. Right? So it's something similar to MPV. It's not exact, but it's something similar. And like I said, SH shuts down directly NF kappa beta. All right. And if you're shutting down RIG1 with the G protein on the MPV, you're not signaling the cell that it's been invaded. it's been infected. So it's very similar to the pseudouridine. It's a different mechanism, but it's a similar way of shutting down the system, and allowing the virus to come in and replicate, right? Just like the messenger RNA needs to shut down the innate immune system, allow for the cell to create protein. So, okay. I'm not sure how long I've been recording on this, but the thing is that hMPV cases are going up in China. They're in pulmonary distress. It's not ARD. You know, at least the news that we know right now, it's not ARDS, but it is pneumonia. All right, so you can have pneumonia, and it could be bad, but it's not ARDS. All right, so it's not, as far as we know, it's not ARDS. So, but it could end up becoming ARDS. But you have these patients that are having the respiratory problems, getting pneumonia, or how they term it in China, white lung, right? And these cases are going up in the geriatric, but mostly in the pediatric patients, 14 and younger. Now the question is why? Why is that? All right. They also have cases going up with RSV, so there's a similar mechanism, RSV and hMPV. Now, why is it similar? Well, the proteins can shut down the innate pathway, but the glycoprotein attaches to the same receptor, and that's heparan sulfate. All right, so the heparan sulfate receptor attaches to the glycoprotein on hMPV and RSV, and the fusion proteins on hMPV and RSV help to fuse with the cell and then release the negatively sensed RNA into the cytoplasm. Okay? So it's a similar receptor, similar shutting down of the innate immune system, right? Now, when you're mid-aged, after pediatrics, but not geriatrics, all right? If you're in the middle, you have a robust immune system. If you're healthy, a robust adaptive immune system and an innate immune system. But there should be more cases with it, not just the pediatric and the geriatric. There should also be a growing number of cases in the middle range of age, even though they have a robust innate immune system or a robust adaptive immune system. Because this is relatively new virus, there's not that many people that have been exposed and creating antibodies or cross-reactive antibodies. So even in this middle distribution of the population of age, they don't really have any adaptive protection to it, even though they may have a robust innate immune system. But if infected, that robust innate immune system should shut down. So the question is, why is it that we don't have more, at least with the way the reports are saying? Now, it could be just because the information coming out of China is so scant that, it may be, there may be more cases also in the middle range, age 20s, 30s, 40s, that we don't know about. It could be happening. Why is it? But RSV typically is for pediatric and geriatric. And that's because of a weakening of the immune system, or not as robust of an immune system, right? And then when you're younger, you're exposed to so many things, and you're building up a memory B cells and T cells, and you get exposed more rapidly to things when you're a kid, versus when you're in the mid range, where you don't get as sick as often if you're healthy compared to when you were in your pediatric years. You know, pediatric years are the times where you get sick all the time because you're building up an immune system to the environment that you've been born into. Right? So that may be a big reason why the RSV and the MPV is happening in the pediatrics. But, is this a big problem or not? We don't know because China isn't really telling us that much. We need to know, is this a problem? We do know this. There's no treatment for MPV. None. It's supportive care. Good luck. All right. That's no. Now, of course, you'll have a community that says take XYZ, take something that has an I in it, or take something that has an H in it, right? We don't know. Is it effective or not? Might be. If you mix it with this and this and this, it's maybe more effective. Maybe, but you can see that when you're shutting down the innate immune system with these 4 proteins, why it is so hard to treat it. Okay, so you have a population that's starting to get MPV, in the pediatrics and the geriatrics, and maybe let's say for whatever reason, the middle age groups aren't getting it, and then all of a sudden you get influenza on top of it. So you have a population, young and old, that are weakened because of MPV. Influenza comes in and could take out more people, meaning death. All right. Or the other way around. People are getting other types of respiratory infections like mycoplasma pneumonia or SARS-CoV-2, right? Or influenza. And then MPV comes in and takes hold even in the middle group. So let's say everyone, the only thing roaming around is RSV and MPV in your community. And you're relatively healthy in the middle age group. Then you're okay because you got a robust immune system, you're healthy, you have a robust innate and adaptive immune system, you're okay. You got the young crowd that's getting sick from MPV, and you got the older crowd that's getting sick from MPV, right? Then all of a sudden, you get influenza or something else, mycoplasma pneumonia or SARS-CoV-2, whatever, okay? And then you're sick, and let's say it's mild or moderate, and after a couple of weeks, you're okay. You seem okay. Your immune system's down. Your immune system's weakened. Your body is weakened. And then now you're more susceptible to MPV or some other pathogen. So the pediatrics get weakened by MPV, and then they get hit by influenza, or they get hit by influenza or mycoplasma pneumonia. They're weakened and they get hit by MPV. The middle group gets weakened by some pathogen other than MPV and RSV, and then all of a sudden they get RSV or MPV because their immune system is weakened from a recent infection with some other pathogen. And the geriatric group has a weakened immune system because of just normal aging, right? But it's compounded because they have RSV or MPV, and then they get hit by influenza and takes them out. So there is an additive sickness component to this, that if your immune system is weakened because of some other pathogen, it adds to the probability of getting other pathogens. All right. So this is part of the reason why it's so important. Is it important to understand specifically MPV? Yes. It shuts down the innate immune system by 4 different proteins. It's affecting children and it's affecting elderly. But the thing is that it's in a constellation of other pathogens that are roaming around in a population that has gone through a major crisis in 2020, and their immune systems are weakened. So they're more susceptible of some sort of compound effect. And that's the reason why I keep on saying this stuff is related. This stuff is related. And that if you catch it based on your prior, either recent or midterm history of illness, pathogenic illness, depends on how you may be reacting to this new infection of a new pathogen. If you have a robust immune system and it's been a while since you've been sick, then most likely you'll be okay with hMPV. You might not even contract, or at least you might be asymptomatic, right? But if you're weakened, let's say a year ago you were pretty sick with, let's say, influenza or something else, mycoplasma pneumonia, SARS-CoV-2, whatever it is, rhinovirus, which is going up in New York. All right, so whatever it is, if it's a recent, your immune system is a little down. So you're more susceptible to H5N1 or hMPV. So the whole H5N1 thing and the bird flu and all that, that's a different dynamic, different way the virus works. Many things have to happen for it to go to human transmission. But hMPV is human-to-human transmission already. All right. So, so what happens with hMPV or RSV may become related to H5N1, because if you have a population that is sick with RSV or hMPV or with SARS-CoV-2, then they're going to be more susceptible to getting non-human to human transmission H5N1 if, let's say, they're exposed to a wild bird during summer. But because in your population, you have a weakened immune system, the circulation of H5N1 starts to happen, mutates, the H protein starts to hone in on the alpha-2/6 receptor, the replication complex starts to mutate where it can produce more virus in the human, and the N protein starts to truncate. Then guess what? Now you have a fully functional H5N1 human-to-human transmission that most likely will cause ARDS. So the point I'm making, and the ones that are physicians, you need to sit down and pay attention here, okay? You got to just close the medical books. You got to close, all your case studies, right, in your clinic, and just listen. There has never been a time in modern human history where we've been bombarded by so many things in such a short amount of time, on top of bad quality of food, bad quality of water, and stressors that affect our endocrine and our immune system. Then what is happening now? Never in modern history. Okay? So you have that component on top of a population that just went through a crisis. In 2020, even though it's 2005 now, so 5 years through, we still are kind of rolling out of this immunologically and endocrine wise. There's still people that are suffering, with these syndromes and weakening of immune systems and autoimmune disorders and all this stuff, all right? So we have an environment where passage of H5N1 through the human population, we have that kind of environment that is conducive to honing in on those mutations that will lead to human transmission. So people will say, well, we got to just, over inoculate. Well, if you use the inoculation with this single epitope of, let's say, H5, like what Moderna's working on, and you mass inoculate, then you're increasing the probability of escape because you're only catching it with one epitope. All right. You can't treating viruses can't be done monotherapy or monoepitope inoculations. Because eventually what will happen is through viruses that have high mutation, which influenza is one of them, they escape. So the more epitopes you hit, this is the reason why natural infection is better. Why? Because you get IgGs, off of the envelope. You get IgGs off of the H protein. You get IgGs off of the N protein. Right? You get because natural infection will break up the virus in all these different ways and presented it on an MHC, you're producing lots of different types of antibodies. It's poly antibodies with natural infection. But when you do these mass inoculations, from Moderna or whatever, it's a single epitope. You're mass doing it. Now look at even at treating with antivirals. It's much more effective treating a virus with a bio or tri therapy than a monotherapy, because you are only cutting off one mechanism. But if you're cutting off 3 different mechanisms, then you're going to be more effective. Now, what can we learn from MPV? Now, I'm talking to the physicians that are listening, because I know the physicians are listening. All right. Listen, why do you think MPV works so well in shutting down the innate immune system? Because it has 4 proteins to shut down different pathways. Let's review again, docs. All right. H shuts down RIG1. M2.2 protein shuts down MABs. Also, it can shut down MyD88, the P protein, shutting down RIG. And M2.2 is also shutting down the pathway of IRF3. So it's hitting multiple points of the innate immune system on how the cell tries to go into antiviral mode. That's why the MPV is so effective. So don't you think that polytherapy is better in trying to prevent viruses from replicating and fusing and releasing? If you can block the release function, you can block the fusion or the attachment function and the replication function of a virus at the same time, you're reducing the chances of escape. Now, do you think that mono epitope inoculations is the best way to handle this? Probably not. And this is part of the reason why we're in the crisis that we're in. We don't have enough docs using common sense. Stop reading the CDC printout. Just sit in your chair, close your books, just use some common sense. There's a lot of information in between those ears. Just close your eyes and use some common sense. And you'll get to the same point that I'm at. All right. Now I'm talking to the overall community. What do you need to do? What you need to do is get informed. All right. Knowledge is power. Don't be fearful. I don't want you to be fearful. But the thing is, you need to boost up your immune system. You need to get healthy. The ones that aren't healthy, you need to start getting healthy. Get as healthy as you can. But I have a feeling that as we move towards the summer months, that H5N1 is going to be starting to circulate and mutate and get closer and closer to more effective human-to-human transmission. That will, if certain things happen, cause ARDS. But a lot of things have to happen before the ARDS starts to manifest. But in the summer months, a lot of people are around and there's more circulation that's taking place. On top of individuals being hit during the cold season with some of these more problematic pathogens like RSV, hMPV, even influenza A, garden variety, all right? So we're moving into a potentiality of an emergent property. All right, so that's my overall assessment so far of hMPV. We need to know what is really going on in China with granularity. Number of cases, presentations, how are they trying to treat it? Is there anything that they've noticed that is effective? Is it mutating? I'm not sure on the mutation rate of hMPV. What are there certain clades that we should be worried about? There's a lot. There's more unknown about this thing than known. So with this problem that we're with it, China has. But please pay attention. All right. Don't just sweep this under the rug. Don't just have cognitive dissonance. This could be problematic. Is it problematic for your life in the United States right now? No. Can these additional pathogens that I'm talking about, like H5N1 and hMPV and RSV, cause an emergent situation where we have an outbreak that's problematic? Now, is it going to be like an outbreak that's just like 2020 in the first wave? No, I don't think so. I don't think we're ever going to see that in our life unless something else is released. All right. But as long as nothing is released, I think that we'll be okay. But like I said, if H5N1, this, hones in and mutates and causes ARDS, which a lot of things have to happen before that takes place. A lot of things have to happen before that takes place. But if that is happening, then you're probably talking about 250,000 people in the United States dying from it. About 5 times the amount of a really bad influenza year, maybe 4 to 5 times. All right, so 200 to 250,000 people die in a year, in a 12 months, situation. Maybe in a 24 month if we're lucky. All right, but it's not going to be as bad as SARS-CoV-2. During the crazy time, during the first wave and the Omicron wave, but that's how I see it. So please help support my work by making sure you share the links. Ask your social media to follow me. Follow me on YouTube. I have 4 channels on YouTube. I have Brighteon, Bitchute, and Rumble. I have Patreon if you want to help support and cover my news, coverage by being a paid member. It's greatly appreciated. My videos are for free. I have thousands of videos like this for free. All right. And it's through the donations that allows me to do this. You can also donate on my website, the-studio-reykjavik.com. All right. And you can donate through Stripe, PayPal, or Buy Me a Coffee. The link is in the description of this video. So please help support, share the links, ask your social media to follow me. Also follow me on X and on GETTR. So thank you for listening. Hopefully you are informed. You understand a little bit more about what's going on. Don't panic. Don't panic. But the reason why MPV is worrisome, and also RSV, is because of this innate immune system shutdown by the proteins that it has. And it parlays into my worry of many people having a weakened immune system because of what we went through in the previous pandemic. Thank you for listening and have a nice day.